welcome back, Year 10. I hope you had a good Easter and had a little bit of a break. It's still strange times, but hopefully you got a bit of sun and ate a lot of chocolate. I know I did. It's good to have you back, and hopefully we can have another good half term coming up. Now, I was so impressed with what you did towards the end of last term, and I think we're doing some really good stuff through this online working. So do keep up the good work. Now, I know a lot of you have done all the Hegarty tasks, which is great. Now, there are a number of you who haven't. I did say they were sort of revision. What I'm going to do is I'm going to leave them open. I'm not going to sign them off. So over the course of this half term, you will need to tick those off slowly. I'm not saying do them all this week. Try and do one or two in addition to any homework I set to try and get those ticked off. They're all revision, and it's important that you do them, even if you've done them before. We will be doing some tests this half term, some class tests through Dr. Frost most probably, and also after half term there'll be sort of bigger tests which will either be through Dr. Frost or they'll be we might even be back at school, but who knows what's going to happen then. Now, in terms of using OneNote, now I know a lot of you are doing this really, really well, but I just wanted to sort of give you a few tips and a few things that I'd like you to do this half term to make your page look really, really nice and neat. Now, so this is a good example. This is not our class. This is year 13. But what I want you to do now is to, every time you upload work, so if you finish today's lesson and you upload work, I do want you to put it on a new page. So to do that, you click on your homework or remote working or whatever you've done it on. Click on add page, and then you put in today's date, so the 20th, 4th, 20, and then you would upload your work, again through insert, picture or PDF if you're doing a printout. And then you would, I'm just going to delete that because, but then you would, and then you see it keeps it nice and neat. So every day you've got a new page that's really nice and neat, and it should look like Alex's does here in my year 13 class. But you were getting really good at using OneNote last time, so keep it up. It's really important you keep everything on there. I will also put on in the show my homework, I'll put a video again how you can upload really, really easily using your phone, which is probably the best way to do it. Or I know a lot of you are using Cam Scanner and things like that. So just keep uploading that, and that's really, really good. Right, okay, so let's get going with the lesson now. All the lessons we've been doing are in the lesson content here, so you can access them even if at your own pace. Okay, and we're going to start today with a Corbett 5 a day. Right, okay guys, I'm going to give you 5 minutes on this, and when you're ready, off you go. Okay, that's about time. Right, here are the answers. Now, strong positive correlation should go. Strong negative is that one. Strong positive, there isn't a strong positive. That's a weak positive there, and no correlation. You should have got x is -9. Standard form, that one there is 7.7088 times 10 to the 11. And the volume of a sphere, we just did that before half term, well, before Easter, so it's 4/3 pi r cubed. You should have got 1436.8 centimetres cubed. So do mark your work there and put in any corrections. Again, that should be under sort of a title of Corbett 5 a day. Keep a record of that in the back of your books, please, on the 22nd of April. Right, today, so you can go back to the front of your books now. Now today, we are doing, so the date today is the 22nd of April 2020, and we're looking at similar shapes, okay, similar shapes, and we're specifically looking at lengths. We'll look at area and volume later on, but we're specifically looking at lengths. Now, there are two properties that make shapes similar, and they have to have both. So one, they must, shapes are similar if one, corresponding angles are equal, okay, corresponding angles are equal, and must be both of these, and corresponding side lengths are in the same ratio. Okay, so corresponding angles are equal and corresponding side lengths are in the same ratio. They must be both. For instance, if you have, say, a square and a long rectangle, I think these are not similar despite corresponding angles being equal. Okay, because point number 2, the side lengths are not in the same ratio, so they're not similar. Okay, I think it could ask you what is the definition of a similar shape, and you would need to list both of those. Right, we're going to go straight in. I've got 3 examples to have a look at today. Example 1, okay, now these two, we've got some triangles, and they are similar. It will tell you in the question that they're similar, or you might see these sort of symbols. That shows that they're equal. Okay, x 6 meters, 2 meters, y 5 meters there, and 3 meters. And the question would be find x and y. Okay, that's the question. Right, now before you start with these questions, it's always good to put an arrow on to show how you get from one triangle to the next. Now, it is also a good idea to sketch them out, which I'd quite like you to do freehand. So to get from the small to the big, you times by, now you find some corresponding sides where you've got length. So we're going to look at the 3 and the 2, because they're corresponding and we know the lengths of those. And it's times by 3 over 2. It's where you're going. So where you're going divided by where you came from. Now, if we go back the other way, times by, well, this is going to be 2 over 3 this time, times by 2/3. Okay? So before I start any of these questions, I would start by putting those arrows in. Now, if we look for x, so to get x, I'm starting at 5. So x will equal 5, and then I follow the arrows times 2/3. Now I can do that in a non-calculator. It's going to be a fraction. 5 times 2 is 10, because that's the same as 5 over 1. And it's 10 over 3, and that's the answer, 10 over 3. I'll leave it as a fraction, that's fine. Now to get y, this time I'm going the other way. I find the corresponding side this time, which is 6. So y is going to equal 6. I follow the arrow, times 3 over 2. is the same as 6 over 1. So that's the same as 18 over 2, which is 9 metres. Okay, so those ones there, don't worry if you get a fractional answer. It's quite common that you do. And that is example number 1. Here's example number 2. To go. So slight advancement on what we've just done. Example number 2. You might get a question that looks like this. Now we've basically got 2 similar triangles without even asking. This one, if I sort of draw it, this one here is similar to the one below. And the reason for that is because this angle corresponds to that angle. That angle there is going to be the same as that angle. You use it because of Z angles. You've got a Z there. And the other one, 1, 2, 3, that's going to correspond to that one there. So we know we've got corresponding angles are the same, and we also know that the lengths are in the same ratio because they all sort of join up and make straight lines. In fact, with triangles, if you've got the same angles, you will also always have the sides in the same ratio anyway. So first thing to do with these examples is to label the sides. So let's put 5.8 on there, that's AB. AC is 5, A to C is 5, and C to E is 4 millimeters there, and C to D, that one there is 3.8. So labeling on the side lengths is a good start. Now step 1 though, that is quite confusing. So redraw in the correct orientation. Redraw in correct orientation would be the first thing I would do. So let's draw the big one to the right. The big triangle to the right, A, B, C. We know that's 5.8 and that's 5 millimeters. Now the small one, now the hard bit here is to get the angles in the right place. Now I know that angle is the triple angle, so this must be the triple angle, and the triple angle there is E. Okay, that tallies up E there. The double angle there, the one I've labelled with a double there, that's going to be a D, and that must mean C is at the top. Okay, so that's the hard bit, making sure you get the orientation right. Now let's just make sure we label it correctly. So C to E is 4 millimeters, C to D is 3.8 millimeters. I've already labelled the big one. And then from this point onwards, so C to B, that's what I'm trying to work out. Let's call that X, and then let's call D to E Y. Again, and now I do it exactly how I did the previous one, so you might want to give this a go yourself and pause the video. But if not, you go from the small to the big by timesing by 5 over 4. And to get from the big to the small, times by 4/5. Okay, right, we'll start with X. Now to get to X will therefore equal 3.8, that's the corresponding side, times 5 over 4, which equals, and then I'll get my calculator out, because this would probably be a calculator question. That will equal 4.75 millimeters. And then to get Y, I would do the other way. So this time it's Y equals 5.8 times, follow the arrows, 4/5. 5.8 times 4/5, which in this case is 4.64 millimeters. And there are your two answers. You can always check if your answer's right. You know X has got to be less than 5, which it is, and Y has got to be less than 5.8, which it also is. So that's example number 2, and please do get these in your book because they're fantastic examples to have. I know it's a few examples today, but they'll be really helpful for revision. Right, example number 3 is, in some ways it's similar. It's a bit easier in some ways, but we'll see why it's not in another. And I approach it exactly the same way. So I'm going to label on the sides again. So B to E is 1.2. C to D is 4.8. B to C is 9. And I'm trying to work out A to B. So let's call that X. Right, now step 1, redraw. So we've got the little one. Let's draw the big one to the right. Okay, and let's label on what we've got. So this is A, E, B. That's X. That's 1.2 meters. On the big one, it's A, D, C. So that's 4.8 meters. Now this length is the bit that sometimes tricks people. It's the whole length across, which will be x plus 9. Okay, that's the important bit there, x plus 9. And now I do the same. So to get from the small to the big, I'm going to times it by 4.8 over 1.2. Now sometimes when you work out this fraction, it's a nice number, and it is in this case, because 4.8 over 1.2 is 4. So I can make that times 4. It's the same as timesing it by 4, which is really helpful. So I start with x, and I use the pair of sides that has x in this time. So I do x, follow the arrow, times 4 will equal the corresponding side, x plus 9. Now I've got a simple equation I can set up. 4x equals x plus 9. If I minus x, 3x will equal 9. And then I can solve that quite easily. X equals 3 meters. Now that was the same as AB. So just for completeness, AB therefore equals 3 meters. And that would be considered quite a hard GCSE question. But if you follow the steps, always redraw, and then follow the steps nice and slowly, drawing the arrows on, you should be okay with these questions. Okay, right, your classwork and homework today. So I know it was a few notes to take today, but they are important. I have set you some Hegarty tasks. They should be up there straight away for you to have a go at. So please do a crack on with those. Now, for each question, I do want you to freehand sketch the shapes. So you can go straight from this point onwards. Okay, that point onwards, you don't have to sketch the original. You're fine to go from that point down, but I do want you to sketch each question and then obviously work it out and then put it on Hegarty like you normally do. And also, can you upload your workings to OneNote, how I described at the start of this video, to make sure you get the date, today's date as a new section, and let's try and keep our OneNote page as neat as you would your exercise book. All right. Now, for some lessons, I will be on Zoom. Not today though. So I'll check in with you tomorrow. Okay. It'll be clear on Show My Homework if I'm available on Zoom for help. But I'll see you and speak to you tomorrow. Well done, guys.